when external force is applied on a fluid which is contained in a container, the same force is transmitted equally and undiminishedly in all the directions. By applying small amount of force, the huge object or large force can be generated with the help of fluid. Critical velocity can be defined once we know the meaning of streamline flow and turbulent flow. Hello everyone. Welcome to session 2 of chapter 10, Mechanical Properties of Fluids. In the last session, we have learnt about the basic properties of fluids. What are fluids? What are the important terminologies that involved in the study of mechanical properties of fluids? In today's session, we are going to discuss about some more interesting concepts. Let us begin with Pascal's law. It is very important question, examination point of view. So what is the statement of Pascal's law? What does it state? It states that whenever an external pressure is applied on any part of a fluid, when the external force, the force which is applied externally on any part of a fluid, the fluid exerts or it transmits the same force or the pressure equally and undiminished in all the directions, which means whenever if we apply some external force on a fluid which is contained in a vessel, it is transmitted, the same amount of pressure is transmitted equally by the fluid in all the directions. So we can understand this by taking one example. Suppose this is a container in which we have considered a fluid. Suppose for example, if I applying some force here in this direction, this fluid will exert this force, or this fluid is transmitting the force in all the directions. Suppose if we consider these are the 4 pistons which is designed, fabricated in this container. So if I apply some force in this direction on one piston, so this force is transmitted equally by the fluid in all the other direction, and it makes the other 3 pistons to move outwards, which means that we are only applying force to the first piston or this piston, and we can observe all other 3 pistons are moving. That is because the fluid exerts the same pressure or the force what we apply on it equally and undiminishedly in all the direction, which results in the movement of the other pistons of this container. So we can understand Pascal's law by this example. I repeat, it states that when external force is applied on a fluid which is contained in a container, the same force is transmitted equally and undiminished in all the directions. This is the statement of Pascal's law. Now we came to know that what Pascal's law is. Now our question is where it is applicable. What are its applications? It has a major application which we come across in our daily life. So now we are going to study about applications of Pascal's law, or the devices that works on the principle of Pascal's law. So the major example or the important example what we can consider for this is hydraulic lift. So hydraulic lifts, we are aware of this, or we are very much familiar about this in our daily life. So we must have all observed this hydraulic lifts in a car washing garages and all. So these are very familiar to us. This is a device which is used to raise heavy loads such as automobiles. So in automobile shops or in service stations, we might have seen this hydraulic lifts, which are devices which used to lift the heavy loads. So these hydraulic lifts works on the principle of Pascal's law. How does it works? How Pascal's law is helpful in the mechanism of hydraulic lift? Let us see that now. So in a hydraulic lift, as shown in the figure, 2 pistons are separated by a space filled with a liquid. So look at this diagram. Here we have piston 1 and piston 2. So as shown in the figure, 2 pistons are separated by a space, and this space is filled by a liquid. Now a piston of small cross section F1 which is used to exert a force directly on the liquid. So here we can observe 2 pistons are having different cross sections. Here the cross section is larger cross sectional area we can observe here, and here we can observe a smaller cross sectional area. So the piston of smaller cross sectional area is applied a force of F1 directly on the fluid. It exerts the force. In return, what according to Pascal's law the fluid will do? It will transmit the same amount of force equally in all the direction, which results in the upward movement of this piston, and this heavy load can be lifted up. That is the application of Pascal's law here. So let us see in detail. According to Pascal's law, the pressure P is equal to F1 divided by A1, because as we all know, pressure is nothing but force per unit area. So here we are applying force F1 to this cross-sectional area A1. So here the pressure applied at this point is F1 divided by A1, and it is transmitted throughout the liquid and to the larger piston of area A2. Because according to Pascal's law, the fluid will exert the same force equally in all the direction, and also the same amount of force will be applied on the larger cross-sectional area F2 by the fluid. So the force of the larger piston is given by F2 is equal to P into A2, because we can calculate here F2. What is F2? How can we write the expression for F2 here? We know pressure is equal to force divided by area. Here the force applied by the fluid is F2 and on the area of cross section A2. So from this we can write force F2 is equal to P into A2. But what is P? We know P is F1 by A1. Let us substitute that. So we get F2 is equal to F1 by A1 into A2. Or from this we can write this A2 is multiplied with these two terms, and you can bring this to the other side. So we get F2 divided by A2 is equal to F1 divided by A1. Since the area of cross section A2 is greater than the area of cross section of piston P1, the force applied by the fluid must be greater than the force applied externally on the piston P1. So here also we can say that the Pascal's law, according to Pascal's law, the external force applied on a fluid which is confined in a cylinder, it exerts the force equally in all the directions. So here also we are applying external force on the fluid, and the fluid in return is applying the larger force on this greater cross-sectional area, which results in the movement of the piston, and the heavy load what is kept on the larger cross-sectional area can be lifted up. So from this what we can understand, by applying small amount of force, the huge object or large force can be generated with the help of fluid. So this is one of the important application of Pascal's law. Pascal's law is also applicable in hydraulic brakes. We might have all heard about hydraulic brakes. So how does this Pascal's law work in hydraulic brakes? To understand these applications like hydraulic lift and hydraulic brakes, we must be very much familiar with the statement of Pascal's law. Unless we know what Pascal's law is, it cannot be understood. The examples cannot be analyzed. Now hydraulic brakes in automobiles, they also work on Pascal's principle. How does it work? You can observe here, this is a schematic diagram of hydraulic brake, where we can observe a brake pedal here, and here we have a master cylinder in which the fluid is present. You can observe, and that is brake oil. Let us now see what is the mechanism of this on the principle of Pascal's law. So when we apply a small force on the pedal with our foot, the master piston moves inside the master cylinder. So here is a brake pedal. When we apply a force on the brake pedal, so this piston moves inside the master cylinder. So what is the result after the piston moves inside the master cylinder? The increase in the pressure is transmitted through the brake oil to act on a piston of larger area. So here you can observe the pressure inside the brake oil, it increases. So here the fluid is present. The pressure in the fluid increases, and which results in the action of this larger cylinder or a piston of larger area. So a larger force acts on the piston and is pushed down, expanding the brake shoes against the inner surface of the rotating drum. Here we have a rotating drum. We have a brake shoes here. Since the pressure here increases, this expands and it will stop the drum or the circular drum to rotate. Here this creates a pressure, and this master cylinder, the area will expand. Due to the expansion of this, here a larger force acts on the piston and which results in the expansion of brake shoes. So what happens if the brake shoes expand? They move against the inner surface of the rotating drum. If they expand and it will disturb the rotation of the rotating drum, the vehicle will be retarded. The motion of the vehicle will be stopped. Since the pressure is created here, the brake shoes will expand and it will stop the motion of the rotating drum, which in turn retards the motion of a vehicle, which means we need to stop a vehicle. The vehicle will stop. Whenever we apply a brake, why does the vehicle stop? Is because of this mechanism. And in hydraulic brakes also, Pascal's law is applicable. This is about one of the important law in the study of mechanical properties of fluids. Our next important concept is streamline flow of a fluid. We are studying about the mechanical properties of a fluid, in which we need to understand what is the nature of flow of a liquid. What can we call this nature of flow, if it is smooth flow or if it is a irregular flow? So let us now study with streamline flow of a liquid. Streamline flow itself says that the regular and orderly flow of a fluid is known as streamline flow. So the differences can be asked between the streamline flow and the turbulent flow. We must know about the meaning of streamline flow first to differentiate between the two types of flows. So streamline flow is nothing but the regular and orderly flow of a liquid. So in daily life we may experience this. Like whenever we open a tap, when the water is flowing slowly, we can observe the soft flow of water like this. We might have all observed this. So this is called as streamline flow. As the tap released more, the force of the fluid will be more, and we can observe the flow is not so regular like this. In that case, as the tap released more and more, the flow will increase, the force of the water will increase, where we cannot observe the soft or the smooth flow of a fluid. Then the water starts flowing so forcefully, which results in the formation of eddies and vortices. So the streamline flow can be understood by considering this soft flow of water. It says that the regular and orderly flow of a liquid. So what is turbulent flow of a liquid then? There are two types of flows. One is streamline flow, the other one is turbulent flow. So turbulent flow, you can look at these two examples, the pictures. This is streamline flow where we can observe the regular and orderly flow of a liquid. And this is a turbulent flow. It is not so orderly, it is in-order flow of liquid. That is called as turbulent flow. Turbulent is just opposite to streamline. It is an irregular and disorderly flow of a fluid. So in understanding this flow of fluid or the nature of flow of fluid, we must understand one more important term, that is critical velocity. What is critical velocity? How to define critical velocity? Critical velocity can be defined once we know the meaning of streamline flow and turbulent flow. Yes, it says that the velocity of flow up to which the flow is streamline and above which the flow becomes turbulent. One particular velocity up to which the flow is streamline means the regular and orderly flow of liquid, above which the flow become turbulent. So this velocity is called as critical velocity. Critical velocity means only up to this velocity the flow will be streamlined. After reaching this velocity, the flow will become turbulent. What is streamline now? It is nothing but the laminar flow or the smooth flow. The regular or the orderly flow of a liquid is streamline. You can observe here, we can see that the molecules are moving in an ordered manner, which means they are parallel to each other. Correct? So in turbulent flow, we can observe the disorderly flow or the irregular pattern of the molecules which are flowing in a random pattern. So this is called as turbulent flow. The velocity up to which the flow is streamlined, after which the flow becomes turbulent, is called as critical velocity. So this streamline and turbulent flow of a fluid can be understood by this example. Look at these pictures. You can observe here the laminar flow or the orderly flow of a fluid, which is nothing but the streamline nature. Streamlined means they are moving orderly. And here we can observe the random pattern. This is not so ordered way. Here everything you can observe the haphazard movement of the particles, and it is called as turbulent nature. And here also we can observe in streamline the flow is so order, and it is called as laminar flow also. And turbulent flow you can observe here there is a random manner of movement of the molecules, and hence we can observe the flow is along this direction, this direction, this direction. In random pattern, the disorderly arrangement of the liquid molecules or the fluid molecules is called as turbulent nature. So now I think it is clear to everybody like how to differentiate between the laminar flow or the streamline flow and turbulent flow. Now we understood what is streamline and what is turbulent. Let us now see what are the characteristics of streamline flow. When we can say that the flow is streamline, or when we can say that the stream is turbulent. Let us see the characteristics one by one. So the tangent at any point on the streamline gives the direction of the fluid velocity at that point. I said that the streamline flow is orderly flow of a liquid particles. Whenever we draw a tangent here, it gives the direction of the fluid motion. So it gives the direction of the fluid velocity at that particular point. If I write the tangent over here, it gives the direction of fluid velocity at this point. So one of the important characteristics of streamline flow is tangent drawn at any point gives the direction of velocity of the particle or the fluid at that particular point. And the motion of liquid particles is parallel to each other. They are not turbulent. Here also we can observe the motion of liquid particles are parallel to each other. So next one is closer the streamline in a region, larger the flow velocity of the fluid in that region. So if we have a region like this, and if we have the closer streamline in this particular region, it says that the velocity of the fluid in this region is more. The velocity is more. You can observe this pattern as well. Here I have written a tangent. So this tangent gives the direction of fluid motion only at the particular points is what our first point says. And we can also say that the orderly arrangement or the regular flow of a liquid which has the motion of liquid particles are always parallel to each other in case of streamline flow. And in any region, if the streamline flow are closer to each other, then we can say that the velocity is more in that region. And next, no two streamlines can intersect. Why no two streamlines can intersect? We know that if I write a tangent here, it gives the velocity of the fluid flow in this point. If they intersect like this, which means here also I can write tangent, and here also in this direction I can tangent, which is practically impossible. So this is because if they intersect, then at the point of intersection, the particle should have simultaneously, they should have moved in two different directions, because I have shown here. I'll show one more example. This is the flow of particle. I can write the direction like this, and if I consider one more streamline flow which is intersecting at this point, it can move on also in this direction, or it can move also in this direction, which is practically impossible. So if they meet at one point, the direction of flow must be in two different directions, which is not at all possible practically. So no two streamlines can intersect each other. It can also be analyzed by considering the other point that in streamline flow only the flow of the particles are parallel to each other. So no two parallel lines intersect so easily, and here no two streamlines can intersect with each other. At a particular point, the flow velocity of the fluid is constant with time, but may vary from point to point or point to other point, which means if we consider one point here, the fluid velocity may remain constant with respect to time at this point, and it may vary at another point. So it is not mandatory or it is not compulsory that the fluid velocity must be equal at all the points. So only at the particular point all the particles will feel same velocity or constant velocity with respect to time. But from point to point or from one point to another point, the velocity of the fluid particle may vary. So these are the characteristics of streamline flow. Let us now see the characteristics of turbulent flow. As I told, turbulent flow is a disorderly arrangement of particles or irregular flow of liquid. So it says that the motion of liquid particles are not parallel to each other. If they are parallel to each other, then it will become streamline flow. In turbulent flow, it is not parallel to each other. The paths of the particle changes continuously, because I have shown in the previous slides the path of the particle, the paths can be changed continuously. But in case of streamline, it is not like that. The paths of the particles will be parallel to each other. They'll move in an orderly arrangement. So this is streamline. In case of turbulent, the paths of the particles may change continuously, and that results in the turbulent flow. Eddies and vortices are formed due to the rotatory motion. Because of this rotatory motion of the particles, we can observe the eddies and vortices, which means not a smooth flow. We can all observe this forcefully flowing water. We can also observe the formation of these eddies and vortices. They can form due to this rotatory motion of a fluid particles. So these are the major differences between streamline flow and turbulent flow. Let us now see one more important topic. Exam point of view, this is very important. It can be asked for 2 marks. That is equation of continuity. What does it state? What's the meaning of this? So it states that the velocity of a flow of a fluid at any section of a tube is inversely proportional to the area of cross section of the tube at that section. So here equation of continuity deals with 2 concepts, that is velocity and area. So it says that velocity of flow of a liquid at any section of a tube is inversely proportional to the area of cross section of the tube at that section. So to understand this, let us consider one example. Here I have taken one tube with different cross sectional area. So here we can observe smaller cross sectional area of A1, and here the cross sectional area is quite larger, that is A2. So let us say that the fluid is moving inside this tube, and A1 is the cross sectional area at the fluid which enters at this point where the fluid enters, and this fluid will moves with the velocity v1 in this direction, and v2 is the fluid velocity when it comes out of the tube. And here the area of cross section of the exit point, that is A2, and here P1 and P2 are the pressure created by a fluid. So according to equation of continuity, you can observe here, wherever there is a smaller cross sectional area, the velocity of the flow of liquid will be more. And whenever there is a larger cross-sectional area, the velocity of the liquid flow will be less. Why? Because the statement of equation of continuity itself says that the velocity of fluid is inversely proportional to the area of cross-section at that particular point. Here we can observe area of cross-section is smaller, and hence the velocity will be more. So whenever we consider a tube or a pipe with smaller cross-section area and a larger cross-sectional area at the exit point, we can observe this. So while entering, the liquid will forcefully enter this, and it will move slowly outside this while coming, because the area of cross-section here will be larger. Since the area of cross-section is larger, the velocity will be less according to equation of continuity. So the expression for this can be written as A into V is equal to constant, where A is area of cross section of the pipe and V is the velocity of the fluid inside. It can also be written as A1 V1 is equal to A2 V2 for the previous example. Since we have 2 different cross sectional area and 2 different velocities with the fluid is flowing, so we can write A1 V1 is equal to A2 V2. Here also you can observe, here the area we consider is A1, and here the fluid is passing with the velocity V1, and this is A2, which is having the velocity of flow of a liquid V2. So in today's session, we have learnt what is Pascal's law, what are its applications, and what is the nature of flow of liquid, how they are classified as streamline and turbulent flow, what is equation of continuity and the expression of equation of continuity. So in our next session, let us learn more interesting concepts based on mechanical properties of fluids. Until then, all of you please take care. Thank you.